All right, good morning. We are now beginning topic C of Module 4. The standards that we're working on are 8EE5 and EE6. This is about graphing proportional relationships, interpreting that unit rate we've always known is now the slope of our graph, comparing different graphs, and then you're going to begin to learn about a new equation, y equals mx and y equals mx plus b, and you'll learn what those different variables in that equation actually stand for, okay? Today's objective for lesson 15/16, because I'm combining these two lessons, is that you'll be able to apply two different methods to find the slope of a line, and you'll be able to compare the slopes of various lines, okay? So you'll know you're successful today when you can find the slope of a line by calculating the rise over run, and we'll talk about what that means later, and by taking 2 points in a line and applying this formula for slope, which is m equals y2 minus y1 over x2 minus x1, okay? So for this lesson, we're going to review some background skills from previous lessons. We'll do exercises together, I'll show you the examples, then you'll do exercises together. I'm going to have you guys work in breakout groups today. We'll close out the lesson, review what we've learned, and then you'll complete the exit ticket, all right? Please make sure that your video's on, your mic's muted, you're showing your thinking and your work on your class cake assignment, you're participating in your group work in breakout rooms, you're having appropriate conversations related to our work, you're communicating any technological issues with me, and you're just continuing to be respectful, responsible, and safe while you're at home. All right, so just to build some background and refresh our knowledge on some skills before we move forward, we're just going to kind of review what we know about the slope of a line. So like when I think of slope, I'm always just thinking of snowboarding, and I know that a few of you guys are snowboarders. I remember that from the beginning of the school year. But it's like the steepness of your incline, okay? So we also say that slope is our unit rate. It's our constant rate. We call it m. That's the variable we use for it. In 7th grade, you called it k. It was your constant of proportionality. But basically, it is the steepness of your line. Okay, it's that rate of change. All right? So we're going to look at the different slopes for these 4 graphs off to the side, and we're going to talk about the differences between them. So one thing I want you to remember is that you're always looking from left to right to classify your slopes. So just like we read from left to right, we look at these graphs from left to right. So what you're always going to do is you're going to identify a point on the graph somewhere on the left, and then find a second point that is somewhere on the right. And you want to make sure that your point is directly on crosshairs, and that means directly where those two lines overlap. All right. Once you see that, you can decide, well, does it look like this is going upstairs or downstairs? And I'm sorry, those stairs look terrible. For this first one, it looks like you're going up. Okay, so this is a positive slope. That's when we're going up from left to right. So this slope would be considered positive. All right. We also have this one to the right. I'm going to find any point on the far left. So the far left is over here. And it looks like there's one right here. And then I'll find another one that's a little bit more down the line on the right. And I'm just looking for one that's directly on crosshairs right here. All right, so from here to this, from this left point to the right point, I'm going down, right? So this is a negative slope. It's decreasing, right? And then we have 2 special lines down below, and we practiced graphing these lines in lesson 14 of topic B last week. So we know that these lines are basically when one of our values in standard form is a 0. So if we either have like x plus 0y equals a number, or 0x plus y equals a number, it'll create these either horizontal or vertical lines. But we have names for these slopes, so you'll hear these names as we move forward throughout this year in math. So this first line, if we choose a spot on the left and then a spot on the right, it's not going up, it's not going down, it's not positive, it's not negative, right? It's just completely straight. This slope is called a zero slope because there's no incline. There's zero incline at all. Okay? And then this other one, you'll notice that the points are directly on the same line. There's not one on the left, there's not one on the right. So this slope is considered undefined. Okay, that's what we call it when a slope is directly vertical. So this is just some review and maybe a little bit of new knowledge too, especially for those last two that I just talked about. We're going to use this as we move forward today and throughout the year. All right, just referring back to our objective today, we're going to find slopes of lines, and we're going to use two different methods to do this. I want you to practice using both methods because you're going to come into some situations pretty soon where you'll need to decide which method is best to use. So the first thing you're going to do is select 2 points on the graph. It does not matter which ones you select, but I'm going to do this one first. So this slope is -1, 2, 3, 4. So it's -4 for my x. And it's -1, 2, 3 for my y. Okay, so that's my first point, and then I'll use red for my second point. Here's the second point right here. So this one is -1, 2 on my x, up 1 for my y. And again, you can select any points you want. For this example, I would suggest just selecting the ones that I've chosen so that your math matches mine. One thing I do want to note before we move forward is that going from left to right, I can see that this is kind of like an incline, so the slope would be positive. I'm just going to make a note of that. It's important to just remember. When we're doing that. Okay. Now what we're going to do is we're going to do what I would consider the easiest way to find slope. And that is to look at these 2 points on your graph, and you're going to calculate what's called the rise over the run. Okay, so we're going to start at our point on the left, and then we're going to move to our point on the right, and we're going to count how many does it rise, how many does it go up, and how many does it run, how many does it go over. So to go from this point to this point, I'm just going to count. Okay, rise 1, rise 2, rise 3, rise 4. So it rose 4. And then I'm going to figure out how many it runs. It runs 1, 2. So my slope is the same thing as saying my rise over run. That's how you would just count it. My slope of this line is 4 over 2. Now I always want to figure out, can that be reduced? Yeah, 4 over 2 is the same as 4 divided by 2. And that is the same as saying 2. So the slope of this line is 2. Okay? And we can just write that as m equals 2. We could just say the slope equals 2, whatever you want to do there. All right, the second way to find slope is a little bit more difficult. And you would use this if you did not have a graph to count. You would use this method if you're just given these points like just off to the side, okay? You don't see them on the actual graph. You can't count spaces on a graph. And it's going to take a long time to really draw out a graph for yourself and then count these. So this is the formula we would use to find slope when we were not given a graph. So it's going to be y2 take away y1 over x2 take away x1. So before I do that, I'm just going to recopy down my points that I'm using so that you can see which ones are y's, which ones are x's, etc. All right, it doesn't matter which points you choose first, but you need to identify one set of values as your first values, your ones, and one set of values as your twos. So I'm just going to say the first point I chose is going to be my x1, my y1. So this one would be x1. This would be y1. Okay? And then this is the second set of points I choose. So I'm just going to say, okay, this is x2, and this is y2, right? Because our values in our coordinate grid are just following the formula x and y. And we have 2 points, so we're just choosing, these are the ones, these are the twos. From there, we're going to plug it in to our equation. So the first one is y2. So I'm starting with 1. Take away y1. So take away -3 over x2 -2 minus x1 -4. So now that I have my values written down into this fraction, into this little equation I'm about to solve, I'm just going to solve it and see what it equals. So before I move forward, I know that these double negatives equal positives. So keep, change, opposite, keep, change, opposite. And now I can solve because it's a little bit simpler. So 1 plus 3 is 4. -2 plus 4, that's 2. What does 4 over 2 mean? That means 4 divided by 2. And what is 4 divided by 2? 2. So you'll see that we got the same answer as before when we just calculated our rise over run. This one's a little bit more complicated to do, but it's not really that complicated, right? So these are the 2 methods that we're going to be using to find slope today. The first method is just rise over run. The second method is our formula. Make sure you have all this down on your work before we move forward. All right, and we're just going to do a second example for you. So I'm just going to start on the left side of my graph, choose a point. This point is at -1, 2, 3, 4, 5, 6. +1, 2, 3, 4. And my next point is right here. This is at -1, 2. +1, 2, 3. So those are my 2 points. And I'm just going to calculate the rise over run. Well, you'll notice this doesn't rise. If I'm going from left to right, to my right point, I'm not rising. And that's because this is a negative slope. Right? It's going down, which is fine. It's allowed to go down. So when we calculate our rise, instead of saying positive, we're just going to say negative because it's going down. So the first thing we do is we go down 1. So our rise is we're going down 1. Remember that tells us this. And our run, how many we go over, is going over 1, 2, 3, 4. So it's going to go -1, down 1, over 4. All right. And this can't really be simplified. If you want to turn it into a decimal, you can. This is the same as saying -0.25. But this is my slope that I've calculated using rise over run. Okay. The next part, we're going to use our formula, y2 minus y1 over x2 minus x1. So I'm going to go ahead and identify where's my y2. So my second y value is right here. That's a 3. So y2 minus y1, my first y value was a 4, over x2. This is my second x value, so -2, minus x1, which is a -6. Okay, and from there I'm going to solve this. So on the top, 3 take away 4, that's -1. On the bottom, -2 minus -6, well, that's a double negative, so these become positive. So this is now -2 plus 6. Well, this gives me 4. And that's exactly what I got up top, right? -1/4. I can't simplify it. I can turn it into a decimal, -0.25. And we were right about that negative slope, right? We can see that our slope is negative. We have a negative sign, and we identified that before just by looking at how many it went down, how many it went over. All right? I think we're going to do one more example before you start practicing this on your own. So please make sure you have all of this down. All right, this is our last example, so just make sure you're asking me any questions here if you're still misunderstanding things. A few conclusions I just want to make about this graph really quick. It's pretty steep. You can kind of see the steepness of this line. So I can tell that this probably has a pretty high slope. I can also see that it's positive because if I'm looking from right to left, it's going up. And I'll prove that with my work. All right, first thing I'm going to do is select 2 points. I see one right here, and this is at 1, 2, 3, 4. So positive 4, negative 1, negative 2, negative 3. And my second point, I see 1 right here. This is at 1, 2, 3, 4, 5. Over 5, up 1. One strategy I want to make sure that I'm just highlighting real quick. You see that I make these little bumps as I'm counting my spaces. It's a really quick and easy way to just make sure that you're doing this right. A lot of times if you don't have numbers on your X and Y axis on your graph, you'll make really small mistakes. You'll think that, oh, that was over 4 spaces, but it was actually over 5. Okay, or you're going to say, oh, that was up 1.5, but it was actually up 2.5. So just make sure you're using this counting method like I showed you in this example. Okay, so I have my 2 points. I'm going to now calculate the rise over run. Remember, this is telling me how many are we going up or down, how many are we going left or right. All right, starting with my point on the left side and moving to my point on the right side. So I'm going to be going up 1, 2, 3, 4. So I was rising 4. And my run, I'm going over 1. 4 over 1 is the same as 4 divided by 1. And 4 divided by 1 is the same as 4. So this is my slope here, m equals 4, positive 4. Now I'm going to use my other method to practice this out. So remember, this is my x, this is my y, this is my x, this is my y. And this is my first point that I found, so I'm just going to call this x1, y1. This is my second point that I found, so this is x2, y2. This is probably where you're going to make the biggest mistake, is just mixing up these values. You might actually do your y1 first minus your y2, but as long as you're writing it down, it'll be easy to keep track. Okay, so I'm going to do y2, which is a 1, minus y1, which is a negative 3, over x2, which is a 5, minus x1, which is a 4. And then I'm going to solve this. So for the top, 1 minus negative 3, I'm just going to do keep, change, opposite. I know that a double negative makes a positive, so this is 1 plus 3, which is 4. On the bottom, 5 take away 4 is 1. That's just the same as saying 4 divided by 1, which is 4. So hopefully you get the picture here. I'm going to have you guys practice on your own for 2 questions. You'll be in breakout rooms working on these. And hopefully, you get the hang of this. It's pretty simple once you get some practice in. Okay? All right, for exercise 1, please complete with your breakout group. Please also do exercise 2 with your breakout group. We're going to come back together in, I think maybe 10 minutes to go over these. All right? Make sure you're having academic feedback with one another. You're showing your work to one another, sharing your screen, asking questions, etc. All right, I'm just going to review this with you. Now, you probably chose different points than I did. It's probably very unlikely that you chose the exact 2 points I chose. No matter the case, it doesn't really change anything. You'll still have the same exact slope that I find if you did your math correctly. Okay, you might have to simplify a little bit more than I do, but you'll get the same slope. So I chose 2, 7, and 3, 5, and you'll see those graphs off to the side. Now I'm going to calculate the rise over the run. Remember, the rise tells us how many go up and down. Run tells us how many go side to side. So from my black point to my blue point, I'm not going up, I'm going down. So it's going to be a negative slope. So I'm going down 1, 2. So I'm going down 2. And then I'm going over 1. Over 1. Now again, if you didn't choose the same points I did, you might not have received this exact fraction that I did, but it will reduce to this when you start to simplify it. So negative 2 over 1 is the same as saying negative 2 divided by 1, which is the same as saying negative 2. So no matter what 2 points you chose, you should have simplified your fraction, your rise over run, to find that the slope was negative 2. All right? The second part of this is a little bit more difficult. You just make sure that you're organized and it'll be fine. So I'm going to do y2, which is a 5 for me, probably something different for you, minus y1, which is a 7, over x2, my 3, minus x1, which is a 2. And I'm going to simplify this. 5 take away 7 is a negative 2. 3 take away 2 is a 1. Negative 2 over 1 simplifies to negative 2. So the slope for this line was negative 2. Check your work. Ask me questions if you have any questions, but hopefully if you did make mistakes, you're able to identify those mistakes. And now we're going to go over exercise 2. All right, for exercise 2, I've selected my 2 points. You'll see the one that's black is negative 4, 3. The one that's blue is 1, 2. Again, you might not have selected these points. It doesn't really matter. Okay, my math is going to look different than yours, but we'll get the same end result for our slope. I'm now going to calculate my rise over run. I can see very clearly that it is not going up, it's going down, so it's going to be a negative slope, so it's going down 1, and it's going over 1, 2, 3, 4, 5. Okay, this does not simplify as a fraction, so it's either going to be negative 1/5 as my slope, or if I want to turn that into a decimal, I could do negative 1 divided by 5 in my calculator, and I get negative 0.2 or 0.20. Okay, from there I'm going to also do my formula method, so I'm going to do y2, 2 minus y1, 3 over x2, which is a 1, minus x1, which is a negative 4. 2 take away 3 is negative 1. 1 take away 4, that's a double negative. Keep change opposite. That's the same as saying 1 plus 4, which is 5, which is exactly what I got up top. Okay, so the slope for this line was negative 1/5. And you can see that it is a negative slope. It's going down. Okay, so hopefully you got this right. Hopefully you feel pretty confident. We're going to close out this lesson, and then you'll do your exit ticket. All right, guys, just to review this lesson, I want to highlight a few different skills that I want you to keep in mind as you complete your exit ticket today. So first, selecting your points on the graph, I want to make sure that you're always just being careful about your counting. Use these little bumps, right, going like this, to count your spaces. It'll just make sure that you're precise in your conclusions, and you'll be able to find those points. Secondly, I want to make sure you're always looking for a point on the left and then a point on the right, because just like we read from left to right, we solve from left to right. Okay? From there, remember that your rise over run, your rise doesn't always have to be rising up. Oh, that's the wrong thing. Your rise doesn't always have to be going up. It can also go down, right, which makes it a negative slope. And your run goes left or right, which can be negative or positive as well. Okay? Keep in mind when you get your slope as your rise over run, you always want to see if you can simplify it. I have this fraction negative 4/3 here, which you could turn into a mixed number, which is negative 1 1/3. Or you could turn into a decimal just by dividing in your calculator. Negative 4 divided by 3 is negative 1.3 repeating. Okay, and then my last strategy for you is that when you're using this formula to find slope, just be really precise about your values, okay? Make sure you're labeling them so that you just know that you're not getting confused when you're plugging them in, because that's your number one mistake that you're going to make today. Is just putting your x2 in the wrong spot, your y2 in the wrong spot, etc. Okay? But hopefully you learned something from this lesson. We are now going to move into your exit ticket, and I will go over that with you. All right, your exit ticket is pretty much the exact same thing that we've been doing all day today. You're going to select 2 points on this graph, find the slope by counting the rise over the run, and then I want you to find the slope by applying the slope formula, y2 minus y1 over x2 minus x1. Okay, take your time, show all of your work and all of your thinking so that I can give you credit for that. And when you are done, please move on to your lesson reflection. It's posted in Google Classroom. Your lesson reflection today says, why would we ever need to use this formula if we can use this? And I kind of talked about this on our first slide. So if you were listening, you'll know the answer to that question. If not, maybe go back and watch this video to get the correct answer. So why would we need to use our slope formula, which is kind of complicated, compared to just counting the rise over run, right? If you finish your exit ticket and your lesson reflection today, work on Moby Max, work on Prodigy extra credit, work on missing and late work.